Ever wonder why some AI systems seem to get things while others stumble? Today, we're peeling back the curtain on a study that's reshaping how we think about AI and data, specifically, how structure defines intelligence. Let's start with a fundamental question. How does AI actually find answers? You know those chatbots that can tell you the capital of Peru or explain quantum physics? They're not just guessing. They're using Retrieval-Augmented Generation, RAG, a process where AI acts like a detective who checks their notes and writes a report. RAG systems pull facts from structured data, like databases or knowledge graphs, and then generate natural language responses. It's the difference between a robot that memorizes answers and one that thinks through them. But here's the twist. The organization of that data matters enormously. Imagine navigating a city with a map missing streets or conflicting directions. That's what happens when AI works with messy or overly complex data. The study we're exploring focused on agentic RAG systems, AI that doesn't just fetch data, but chooses what to look up, interprets it, and builds queries dynamically. Think of it as an AI detective that doesn't just search a file cabinet. It decides which files to open and how to connect the clues. The researchers tested two core approaches to structuring knowledge. 1. Simple triples like basic building blocks like Lego pieces. 2. Complex logical rules like, if a person is a parent, they must have at least one child, more like detailed blueprints. They also compared real-world knowledge graphs, such as KnowWhereGraph, which links climate data, agriculture, and demographics, and Enslaved, OrgHub, a tool for exploring the transatlantic slave trade. The goal? To see how different maps affect AI performance. Here's what they found. Simpler, clearer structures outperformed complex ones. When AI had to navigate overly intricate rules, it struggled, prioritizing irrelevant data or missing critical connections. But with clean, straightforward schemas like KWG-Lite, the system excelled. GPT-4o, for instance, generated accurate queries 83% of the time for basic questions when given simple data. But why does this matter? Consider an AI helping historians trace slavery's legacy or doctors diagnose diseases. If the data is tangled, the AI might hallucinate, fabricate facts that don't exist. The study showed these errors spiked with messy schemas. However, when data was organized with clear rules like KWG-Lite, the AI stayed on track. This isn't just about code. It's about designing systems that work with humans, not against them. The future of AI hinges on balancing depth and clarity. Too simple and you lose nuance. Too complex and you risk confusion. The study suggests we need to build data structures that are both rich and easy to navigate. So next time you see an AI get something right, remember, it's not just smart. It's well-structured. The next frontier of AI isn't just about bigger models, it's about better maps. Thanks for watching and stay curious.